Okay, today we're going to look at graphing quadratics and the vertex form. So right here we have three different quadratics. How do I know that the first one is a quadratic? It has an x squared. How do I know that this one is a quadratic? Actually, exactly, because you have that squared there, and we were just talking about how you would have to FOIL that. Your x is eventually going to be a square. And then how do I know I'm going to end up with an x squared here? Same thing, FOIL. When you go x times x, you get x squared. So let's go ahead and we're going to use technology to graph the following quadratics and sketch the graphs, labeling some key points. And the key points that we're looking for are the vertex and the x and y-intercepts. Okay? So, and there might be certain forms of these that are going to be more friendly to finding those. So I'm going to use my handy technology here. Okay, and this is Desmos. And I've already pre-programmed some of the equations in there. So if you're not sure how to type them in, that's something we could talk about. Okay, so if I click on the one, okay, that's that one. That's the first one. So we're looking for some key points. And if you actually, if you have a touch screen, you can click on the points and it should tell you the ordered pairs. What do we call that point right there? The vertex. And then here we have x-intercepts. And there's our y-intercept. I can actually, because this is a touch screen, I can just move it around. And I have some of the key points, okay? Will you do me a favor and write some of those down for me? So we have the vertex, the x-intercepts, maybe I'll remember them, and then the y-intercept. Okay, so that's the first equation. And then if we go to g of x, all I have to do, because I've already pre-programmed it, I didn't want you to have to sit and watch me type it in. That would have been hard to watch, right? And so I click on it, and now I'm seeing the next equation. But wait a second, where did it go? Why don't I see it? Oh, because it's the, what? It's the, what do you notice about these two equations? They're exactly the same. Okay, so now I'm going to click on h of x, and where did that one go? It's the same. They're all the same, but they look so different, right? They're exactly the same. So that's just something interesting to notice. We could have three different equations. Do these equations look the same? No. So we saw, and we're just going to sketch it. I'm not going to do, a scale, just because we're just going to draw a little sketch of the graph. So this one looks like this. The vertex, you said, did you write that down? What was it? 5, 9? Okay. What were the intercepts? The x-intercepts, I should say. They're on the x-axis. 2, 0. This one must be 2, 0 over here. 8, 0. And then there was a y-intercept. Does anybody remember what that y-intercept was? It was... Well, actually, could you tell just by looking at the equation what the y-intercept would be? It would be actually 0, negative 16, right? 0, negative 16, because just like when we were graphing a line, what do you do to find the y-intercept? You would plug 0 in for x, right? Because all along the y-axis, x is equal to 0. And then if you plug in 0 for x, what's the only thing that's going to be left? Negative 16. So in other words, f of 0 equals negative 16. Now, yesterday we were looking at the point-slope form of an equation. And you remember that we were able to find the point when the equation looked similar to this. And so what was a point that you can see based on that equation, just thinking about what we learned yesterday in the point, or the other day, in the point-slope form? What point do you see? Yes, you actually see the vertex. It's going to be the x value is the 5, and the y value is the 9. This is the x and y of the vertex. So, funny enough, we call this one the the vertex form. So from this form, you don't see the y-intercept here. You would see the y-intercept in this form, which we actually called standard form. But here, we call this one vertex form. And you actually see the vertex. And then we go over 5, up 9. So we're calling this point 5, 9 is the vertex. And then we have these. So it's the same. It should be the same. I mean, my sketch is not. You guys have pencil. Maybe I should use a fancy pencil so I can actually erase. I'm going to give a plug for my, this is so fancy to write with. This is the 0.9. Got the fancy eraser. Okay. Anyway, so I could have drawn it a little nicer. But here we have the x-intercepts, which are 8, 0, 2, 0, and then the y-intercept again, 0, negative 16. But from this form, you actually see that vertex, okay? And then the last one we said is the exact same picture. So if we sketch a graph of this, okay, we still have our vertex at 5, 9. But what are you seeing from this actual form? What kind of form do you think you would call that as a quadratic? And this is down here, negative 16. We call that, as opposed to standard form, it's, what is it? Factored. It's actually, yes, it is called factored form. Now I want to switch back to pen because I think the pencil's not dramatic enough. So this is what we call factored form. And what part of the graph do you think we're able to easily find from the factored form? The x-intercepts. The x-intercepts. Because remember, a long time ago, we would solve by setting x minus 2, well, we can write it make negative, x minus 8. We could set that equal to 0, and then we get x equals 2, x equals 8. That means right there that the y is equal to 0, and y equals 0 is the equation of the x-axis. So when we solve a quadratic by factoring, we are finding what? You say it? The x-intercepts, exactly. So the x-intercepts are going to be this 2, 0, that's a positive, and 8, 0, because these are my x values when y is equal to 0. Okay, so some of the questions you have here, what do you notice about all three graphs? And you noticed right away when we used the technology that they were all what? The same. Okay, what can you immediately determine in the first one? You can immediately determine just by looking at that standard form, it's not factored, you can immediately determine the y-intercept. So standard form is what you need to find the y-intercept. And I didn't put 2 because there's only one. So I didn't say intercepts. Notice that. Okay, there's always only one y-intercept, and we use standard form to find that out. In fact, we found f of 0 equals negative 16, and that was the y-intercept was 0, negative 16. So whenever you plug in x equals 0, you're going to find the y-intercept. What can you immediately determine when you just look at? You shouldn't have to really do very much math, but for part B, when you look at this form, what can you immediately determine? The vertex. So that's what's so convenient about having that form, is that the vertex literally could fall out of that form. So for g of x, we have it in vertex form, and that gives us the vertex. And it's going to be, we call the vertex, and later on we're going to talk about this more, hk, but this is the same thing, xy, and it's going to be the opposite of that, of the x coordinate is going to be the opposite of that value, and the y coordinate is going to be the actual value. So that's why we said it was 5, 9 was the vertex. And what can you immediately determine from the function h of x? So we looked at h of x here. What can you immediately determine from that form? It's in factored form, and we said it gives us the x-intercepts. X-intercepts come from factored form. Okay, and they're going to be whatever the x values are coupled with the y is equal to 0, right? So in this case, we got 2, 0, 8, 0 for the x-intercepts. So the x-intercepts always happen when y equals 0, and we solve. A lot of times we solve. We don't have to solve that way. There's other ways to solve, but the way we have been most familiar with is solving by factoring. Okay, any questions about that? What I'm going to ask you to do now is try the next two problems, and then we'll go over those.